Thanks for inviting me here. It's a really big honor. I kind of thought to myself, was I invited because of everything that I do or because I'm a Technion graduate? I guess the answer is the latter. So I was asked to talk about how can the academia and the industry work better together in the future. And I will talk about that. But I do have a hidden agenda, which I want to unhide. The hidden agenda is, actually let me ask a question first. How many of you in the audience are computer scientists? Can you raise your hands? Okay, probably 5 or 6. By the way, computer scientist doesn't mean that you have to have a PhD in computer science. Bachelor of Science, like I am, is enough. So again, how many computer scientists? Still the same? Okay, a few more. Okay, so my hidden agenda is that when we stand or sit in this room 20 years from now, there'll be about half of the room that will raise your hands. And I'm going to take the next 25 minutes or so to try to convince you why that is important and why that's going to happen. Is the hidden agenda clear? All right. So, what do you see here? I think you didn't tell them I'm going to ask questions, right? You thought I'm just going to talk and they will listen. So what is that? It's a field. It's a field of crops. And my question is, if you look many years into the past, before we jump into the future, what percentage of the Earth's population was dealing with getting food into our mouths through agriculture or hunting or any of that? What percentage was that? 99%, maybe 100% at some point in time, right? What percentage of the world population does that today? I heard 3%. 4%. What do the other people do? They found other things to do. Okay? The world has changed in the last 300 years, and most of us do something else. We don't do agriculture, we don't do hunting, we do something else. And what I'm going to say and try to talk about is that the world will change farther and way faster in the future. And we need to adjust to that new world that is going to change. And it's changing way, way more rapidly than it changed ever before. It always fascinates me that only 200 years ago, the fastest we could move was the speed of a horse. And then in 200 years, we advanced so much to travel the speed of a spaceship or an airplane, all these kind of things. The world is changing much faster than it ever changed. And what I'm doing in the next maybe 10 minutes is to talk about the jobs of the future. Because for many of us here, including myself, the jobs of the future do not matter. We will not work in these jobs. We're too old. Well, I am, maybe you are not. But for many of the youngsters we educate today, either in schools, high schools, or academia, this is the future. The future is 20, 30 years from today. If they are 50 now, or at the Technion, if they're 18 or 21, 20 years from now, this is their career. This is their future. And we better prepare them for that future and not for what exists today. This is taken from a blog by a futurist, Thomas Frey. You're welcome to look him up on Bing later. This was a joke for those of you. Being a futurist is actually cool because no one really knows if what you're saying is going to happen or not. So, future is speculation. But Thomas Frey is one of the best speculators that I know, and he has this blog about the jobs of the future. And if you look it up, and you look at the 162 jobs that he is outlining for the future, I guarantee you that you will not recognize or understand at least half of them. You will look at the job description, you will not understand it. Just as when I studied computer science here in this institute about 30, 35 years ago, not many people outside of the campus understood what computer scientist is or what software engineering is. My parents didn't. My friends didn't. There are many jobs here that we don't recognize. They are different. They are the future. And what I wanted to do in the next couple of slides, and actually a couple of videos, is to take you to some of these jobs. I mean, you can look at some of the jobs on the slide. We're not going to go through all of them. But let me take you through one, which is cars. So how many of you think that 10 years from now, we will still drive cars? Okay. How many of you think that 20 years from now, we will still drive cars? 30 years? Okay, so you're a common audience for this question. Somewhere between 10 to 30 years from today, we will not drive cars anymore. Actually, it will probably be a crime to drive a car because we kill people. Just open the newspaper. We kill people every day. So if you kill people, it's a crime. So we will not drive cars anymore. Does it mean that drivers will not have work? As I said, farmers did not, used to farm all of us, and now we don't. Most of us don't. So if we're not going to drive cars anymore, what are we going to do when we move from one point to another? How are we going to use the time? We're going to shave or put a makeup? We already do that today. So what are we going to do? So here's the job of the future. Design the experience for us. It's going to be a different experience, being in a car in which you don't have to drive. So that's just one example of a job of the future. Take a look at another example. Bottom right part, body part and limb makers. We will all change body parts. We'll change limbs. We already changed some of our body parts today. Most likely, they're going to be computerized to some degree or another. Someone will have to make that. Someone will have to design, build these body parts. It's a new job of the future. Another example. Many of us will live more and more in the virtual space. You may not like it. It doesn't matter. Many of us spend more and more time already in the virtual space. We spend time in front of the computer, on our smartphones, on the internet. Some of us put these cool glasses on that you can actually go into a different world, into a virtual world. This is how the future is going to look like. How many of you read sci-fi? Okay. Anyone read Ready Player One, the book? If you didn't, take a look, even if you don't like science fiction, just to understand what the future can be about. Again, whether you like it or not. So if you're in the visual space, most of our time, someone has to design it. Someone has to design our appearance in the visual space. These are jobs that do not exist today. Or they start to exist today. They will exist in the future. And again, the list is long. And again, I'm not going to go through the entire list. I want to take you to a job of the future, which is slightly different, which is an IoT data creative. One industry where it's harder for us to think about as a computer science industry is fashion, clothing. And I'm going to run a video and then talk about it.
In the late 90s, I was working as an interface designer in Chicago, and I was really obsessed with interface design, but I sort of realized that interfaces were going to expand beyond just the screen and the mouse and the keyboard. I had heard about this institute in Italy called Interaction Design Institute Ivrea, and I went there with an interest in interface design and an interest in fashion. And that's where I met Francesca.
I was working as a normal fashion designer. It was like my first job out of university. I was a Valentino. I started to have all these ideas about like fashion that does a little more. And then people just tell me, no, you cannot do it.
When we left the Interaction Design Institute of Rea, we formed Cute Circuit around this concept of designing advanced fashion that uses wearable technology. When people say wearable technology, they immediately think of either Google Glass or some bracelet that you strap on the wrist. But both of those solutions were taken pretty much from a technology point of view. They thought, oh, let's think of some technology and figure out a way to strap it on the body. And I think that for that reason, people can't imagine them wearing it, because if you want to wear something, it has to be first and foremost a piece of fashion. So we design the fashion, we design the technology to go inside, we even write the software to control it and the software that runs in the technology. So we can make a dress that looks perfect like that because we design every single little aspect of it.
Developing all our own materials, I think the most amazing thing is that we convinced the manufacturer to manufacture small conductive ribbons for us. And that is definitely a game changer, because at that point there are no electric wires. They feel horrible in a garment. We designed the way that we interconnect smart fabrics, microelectronics, and traditional textiles in a manner that allows the garments even to be washed.
Most of our garments are also connected to the internet, so we have truly telecommunicating garments.
So at the Barbican Digital Revolution exhibition, we're going to be displaying this beautiful miniskirt that's going to be controlled via a small tablet, and it's going to display tweets from the people visiting the exhibition and a series of animations.
So this is as most traditional industries you can think about: textile, fashion, clothing. And it's going to go into computing. Now, it's important to understand the difference here. This is not computers to assist an industry, to do the payroll, to do the design, to do the finance. This industry in the future will build computers. The fashion industry will build computers. We will wear wearable computing. So the industry will actually manufacture computing and high-tech, not just use computing and high-tech to assist whatever it does. Okay, that's one of the things that we have to understand. I'll talk about it briefly later. We call it at Microsoft a digital transformation. The world is transforming into digital. Another example. We talked earlier about spending time in the virtual space. If we spend time in the virtual space, I said someone has to design it. But we can also use the virtual space to design the physical space. And the next video will show that.
In the real world.
You get the physical model as a focus point for the team to collaborate around. And you get the hologram with the flexibility, with the ability to run quick iterations.
You'll see how we've brought in the courtyard that you suggested. You see that mouse go off the screen and into holographic space, and you're then interacting with the hologram with the mouse.
The thing that we can do for architects is really give them much higher confidence around decision making. One way we can do that is we can allow them to literally immerse themselves in the scene that they're building and see street side how the building's going to look.
Visualizing design data in the context of the real environment is a much better way to make sure that the design is implemented correctly on site.
Microsoft HoloLens allows you to collaborate with somebody regardless of distance, like they were there. Hello there.
Hey, Igor, where they're trying to put this door, there's a beam behind here.
I'm looking at this beam. We're interacting with it about a problem that we can see and being able to solve that problem with all the data that we need in front of us in real time.
When I'm talking about enterprise construction, I always compare it to people trying to make music together. Each one of them is contributing to the harmony, but they all should be completely synced.
My gray hair says I've been doing this for a while. I've seen a lot of these new things come and go. And I expect in 5 years, we'll all be interacting with the world with this kind of technology.
So there was a hidden advertisement for Microsoft HoloLens here. But take any virtual reality glasses and you put it on and you're in a different world. And you can design buildings. You can actually walk in the buildings before they ever existed. 6 months ago, I walked on Mars. I did. I put on HoloLens, and I walked around in a room, in the first 30 seconds, you understand that you're in a room. After about a minute, you don't know that you're in a room anymore. You think you walk on Mars. And for someone like me who will never walk on Mars in my lifetime, this was an amazing experience. So that's what virtual reality can help you do. Another job of the future. If we're going to have more and more computing and robots and autonomous cars, someone needs to think about how are these all going to behave. There's a famous example that people give. If there is an autonomous car and a kid runs into the path of the car needs to decide whether it's going to stop and save the kid. But then the truck from behind is going to probably kill everyone in the car, or just run the kid and save the people in the car. How do you make that decision? You know, human makes this decision on a daily basis. How can a car make this decision? Who's going to tell the car what decision to make? Who's going to program the car to make this decision or another? We don't know. This is the job of the future. You know, ethical technology. Freelance biohackers, we talked about that. People who will build body parts which have computers in them, you know, memory, networking, everything within our bodies. One of the things that we start to realize is that evolution doesn't keep up with the pace of technology right now. You know, 3,000 years evolution kept up with the progress we made. It's becoming harder. We don't evolve fast enough right now, so we'll probably need some help. Many companies, including Microsoft, has a cloud. Most of our data today is in the cloud. Cloud, for those who do not know, is a bunch of servers, memory, storage, somewhere in the world. And your data, most likely right now, your mail, is on that server. You have no idea where it is. You don't care. You get it on your device. You don't care where the data is. Usually, we build these clouds or big farms of computing in places that are cheap from a real estate perspective, and also where energy costs are low, because such a farm creates a lot of energy and needs a lot of space. And where is a better place to do that than in the water? Water is about 2/3 of our planet. You get cooling of the heat for free. And I want to show you a quick video of one of Microsoft data centers, which is actually underwater.
Pump is off.
And pump's off.
Okay, pump's off. Flip switch. Send the divers in. Humidity's dropping. That's good.
Okay, and is everything stable now?
Everything is stable and on. What's our power consumption?
27 kilowatts.
All right.
NADA could have a lot of impact, both currently and into the future.
It's not like a moonshot in the sense that it's just some outlandish thing. It's actually a viable product that we could make.
So if there is an underwater data center, someone has to maintain it. So big data divers, a job of the future. So to summarize my point, there is something at Microsoft we call digital transformation. And what I'm saying here is that more and more of the jobs of the future are going to be technology-based. We will need more computer scientists, and all the industries are eventually going to become high-tech industries. I don't think we should talk about the high-tech industry anymore. we should talk about high-tech for all industries. I don't think there is a high-tech industry anymore. Because as I just showed you, every industry is going to be high-tech. It's already happening. I gave a presentation. I do a presentation like this many times in front of schools, mostly to talk to kids about their future. If I talk in a school and the kid is 15, and they need to decide what they're going to do in the future, they better understand what the future is going to look like, because this is their future. I was in I was talking in a school in Tirata Carmel, which is actually a city nearby, for those of you who do not know, a few months ago, and a kid stood up and said, so what's going to happen? Are the robots or artificial intelligence going to rule over us? Are they going to take over? You know, there's a constant human fear that someone else will take over. And we don't know if that's going to happen. But this is what the future is going to be. It's going to be like. By the way, what I answered to that kid, which thinking later it was probably not the right answer for that kid at that age, is how do you even know that we are not artificial intelligence? We don't know. We really don't know. So this is the future, and the point that I want to make and close with that, and then just one more slide specifically about Israel and what's happening in Israel, is the future is about digital transformation. Every industry is transforming right now in front of our eyes. Again, we talked about cars. I don't know how many of you know, but Israel is a hub of car innovation. How many of you know or remember what is the last car we ever manufactured in this country? Susita, how many years ago? 45. Okay. So we haven't manufactured a car for more than 50 years. And we are an automotive powerhouse, make no mistake. We are an automotive powerhouse because a car today is computer on wheels. That's what a car is. It's a computer with memory, CPUs, networking, that someone attached some wheels to it. That's what a car is. And while we are not great in cars, we leave this for Germany and Japan and the United States, we are actually very good in computing. And that's why all the car manufacturers, I met a board member of Mercedes-Benz this week, all car manufacturers, Ford, Mercedes-Benz, GM, they're all opening R&D centers in Israel. Because this is what the automotive industry is about. It's about computing on cars, computing on wheels. So automotive, we talked about fashion already earlier. We're going to generate wearable computing. Industries like banks, health, I mean, it's actually quite obvious to most of us that while a computer cannot make a surgery on you yet, a computer can definitely give you a better diagnostic of what you have than a doctor. Not because a computer is better than a doctor, it just has access to way more sources of information than a doctor will ever have. And that's just going to improve in the future. So, bottom line, world is changing, the jobs are changing, and we better prepare our kids, our students, to that future. And this future has more technology, has more computing, has more coding, and more computer scientists. And if I summarize last slide by looking at Israel. So we are not in a good situation right now. And I apologize for concluding this with a kind of a negative note a little bit. We are not in a good situation right now on many fronts. I mean, you look at education, high schools, in half of the schools in the country, you cannot even study math at the highest level. We just don't have the teachers to do that. The rates of students that learn the highest level of math has been declining in the last 10 years. And finally, in the last 2 years, with the help of our Ministry of Education and a special program, it started to climb up. And by the way, if you wonder, there is a very high correlation, 91%, between students that study 5 units of math and students that go to computer science. So this is a very high correlation. So that's one example. If you look at academia, about 6% of the total students in academia today are around computer science or math or electrical engineering. So a very small number compared to what we need. I looked up the numbers, and my friend Irad Yavne and Boaz Golani helped me with the numbers. The industry, the academia in Israel is generating about the same number of computer science students, or graduates, today as it did 15 years ago. Do you want to know how, what was the high-tech community in Israel, or the number of engineers in Israel back then and now? It doubled, almost, 70% more. So we increased the number of engineers in this country by 70%, while the academia has not created more engineers. So where is it coming from? Some of them come from colleges, some of them come from just, army. That goes to some units in the army. But the bottom line is that we need the academia to create more computer scientists. It's really important, and I think this is the audience that needs to hear that. Because we will not be able to keep up with the need. The growth is amazing. I was in a meeting with, on Thursday with Naftali Bennett, who is the Minister of Education, with some people from the industry. And Naftali Bennett asked me, so how many engineers do we need? And my answer was, I don't know. If all these industries are going to move to high-tech, as I just showed you, it's infinite. We need as many engineers as you can ever, computer engineers as you can ever create. I cannot give you a number. If textile is going to be high-tech, I don't know how many engineers they need. So this is what we are facing. And finally, from a demographic perspective, we have quite a few populations or minorities. Actually, women is not minority, but Arabs and Orthodox Jews are minorities that just do not participate enough in high-tech. We cannot get enough women into high-tech. We get about 30 to 34% of them in the academia, learning computer science, but about 20% in the industry. Something we have to figure out. That's not for the academia to figure out. We have to figure that out. Arabs, 18% of the population of the country, less than 5% in computer science, in high-tech. The Technion helps a lot in that. About 25% of the students in the computer science departments are Arabs, which is a great sign for the future, but there's still work to do. And Orthodox Jews, again, about 12% of the population in Israel, almost none in computer science or high-tech. So there are some minorities we can leverage before we will have to do, if we will ever do, what the United States did when it was in our situation 15 years ago. What did they do? Open the borders, open the gates. Indian, Chinese, Israelis. I spent 13 years in the US. There's still things we can do before that. But again, the most important thing is to educate and talk to the young generation about what they want to do in the future. Thank you for listening.